let's talk about ellipses. So an ellipse is kind of like a circle. We define it as the set of all points in a plane where the sum of the distances from two distinct fixed points, called the foci, is a constant. So, like with parabolas, we have both a horizontal and vertical ellipse. They're pretty similar, especially if you look at these equations. This is kind of the most important part, as in our general equation. You notice the only difference is that the a squared value is below x for our horizontal. The a squared value is below y for our vertical. Essentially, all that means is that the distance from the center to the vertex versus the the distance from the center to the left or rightmost edges is larger on a horizontal ellipse as compared to the vertical edges. So for a vertical ellipse, notice the edges or these, the distance here is longer. In addition, the foci is on the longer axis, which we would call, like this long axis, we call the major, the short one we call the minor. So horizontal ellipse, major axis is horizontal, the foci are on it. Vertical ellipse, major axis is vertical, the foci are on that. In terms of the equation, HK represents the center. These equations, notice, are always set equal to 1. Unlike circles, where like your radius is over there. And whichever number is larger, that tells you whether it's vertical or horizontal. So if your number below x is larger, we would say it's a horizontal ellipse. If your number below y is larger, we would say it's a vertical ellipse. And the square root of those numbers tells you the distance from the center to those edges. So the square root of a, or just square root of a squared, or just a, that tells me this distance here, as well as over here. The square root of b squared, or just b, would tell me this distance here. So the square root of whatever is under x tells you your distance there, under y tells you your vertical. Last thing is kind of determining where the foci are. So as I said, the foci are always on that major, or the longer axis. And the way we find that is by doing a squared minus b squared equals c squared. And the distance from the vertex to the foci is just a distance of c. Okay. So we'll do some graphing together as we go through here. It's kind of a lot to keep track of with all of these different types of conic sections. I almost said functions, but they're not functions. Well, except a parabola. A vertical parabola is a function. But so there's a lot to keep straight, so we'll try and talk through some things as we go through. So being able to determine whether it's vertical or horizontal isn't as necessary as it is for parabolas. So we'll kind of walk through step by step. We'll go through a couple problems together, and then I can talk through kind of how we come up with some of these things. So to start, just remember in general, our form is x minus h squared over something plus y minus k squared over something equals 1. So it's got to be set equal to 1, like this one is. And our vertex is told by whatever those x and y values are. So in this case, our vertex, or sorry, I keep saying vertex. Our center is by those hk. So our center is at hk. Now, the value under x, the square root of that, so in this case it would be 8. That tells you how far away the edges of your ellipse are to the left and right. So we go over 1, 2, 3, 4, 5, 6, 7, 8. So, and to the left, 8. So I know these are to the left and right because it's below our x value. So x tells us the horizontal axis, y tells us the vertical. So for our y value, square root of 9 is 3. So our distance up there is going to be 3. So in this case, our major axis would be horizontal, our minor is vertical. So we would call this a horizontal ellipse. And you can always tell by whichever number is bigger. So since 64 is larger than 9 and 64 is below x, it's horizontal. When we're thinking about our vertices here, vertices just refer to the major axis. These points up here, we would call those co-vertices. So I may ask you to find those at some points. But the vertices are on the major, so that would be at 8, 0 and negative 8, 0. The co-vertices are on what we call the minor axis, which would be 0, 3 and 0, negative 3. Last thing is the foci. So to find our foci, we'd take a squared minus b squared, and that's equal to c squared. So notice it's different than the Pythagorean theorem, a squared plus b squared. We do have minus. So a squared and b squared kind of nice for us. A squared is 64, b squared is just 9. So we get 55 for c squared. So c is equal to the square root of 55. Which the square root of 55, that's somewhere between 7 and 8, since 7 squared is 49, 8 squared is 64. So it's somewhere between 7 and 8, so about 7. So our foci would be about there and there. So notice the foci would be a distance of c from the center on the major axis. So it would be root 55, 0. And negative root 55, 0. And you do have 2 of them. Foci is plural for focus. So we will have 2. Let's look at number 2. So in this case, again, we can find our center right off the bat. So it'd be 4, negative 1, so h and k. So 1, 2, 3, 4, and negative 1. As I look down below, we look which is larger to determine our a squared and our b squared. 25 is larger than 16. So it's going to be a vertical ellipse. This will be our major axis. The square root of 25 is just 5, so a is 5. So our vertices will be 5 above and 5 below the center. So up 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5. So that's at 4, 4, and 4, negative 6. Our co-vertices will be a distance of b, so square root of 16 is 4, so 4 away from the center, but on the x. Okay. We still need our foci, so that's always a squared minus b squared equals c squared. So in this case, a squared is 25, b squared is 16, so we get 9 equals c squared. Square root of that would be 3. So it'd be a distance of 3 from the center on the major axis. So the major axis is our y, because the number under y is larger. So we go up 1, 2, 3, and down 1, 2, 3. Okay. So our foci will be at 4, 2, and 4, negative 4. As we compare both of these graphs here, notice the location of the foci. So on the first, our foci are very, very close to our vertices. On the second, they're a little further, a little closer to our center. The more your ellipse looks like a circle, the closer they are to the center. In actuality, a circle is really just the equation of an ellipse where your a squared and b squared have the same value, which would make your c value just 0. So the foci are just like at the center. Yeah. Okay. So let's look at number, So we have a couple more. Let's do number 4 together, and I'll have you do number 3 on your own. So we'll do, I'll have you start with number 3 first. One thing you want to notice is that it's not set equal to 0. So the first thing you want to do is divide everything by 16 so that it is, or sorry, set equal to 1, not set equal to 0. Divide everything by 16 so that it's set equal to 1. So that would cancel there. We just have x squared plus y squared over 16 equals 1. And you could write this as x squared over 1 so that it's in our kind of proper form. And then I'll have you go ahead and find the center, vertices, and foci. So you can pause it and try that. Okay, we're back. Our center would be at 0, 0. So as we look here, it's going to be a vertical ellipse because our 16 is larger than 1 and 16 is below y. So our a value is going to be 4 because a squared is 16, square root of 16 is 4. So we'll go up 4 and down 4 from the center. our b squared is 1, so that means b is just also 1, so those would be our other points. So our ellipse will look like this, very thin ellipse. The vertices were at 0, 4, and 0, negative 4. To find the foci, we do a squared minus b squared equals c squared, where a squared is 16, b squared is 1, so c squared is 15, or c is root 15, which is going to be very, very close to 4. So our foci will be right up there at 0, root 15, and 0, negative root 15. All right, last one here. So this one's looking a little wonky probably. So for us to write an equation of an ellipse, it's got to be set equal to 1. That's kind of the main idea. And your x has to be in parentheses, same with your y. So we're probably going to want to do some completing the square here. So let's at least just get our x's kind of by each other, same with our y's. And 4y squared minus 8y. And I'm giving myself a little space because I know I'm going to want to complete the square. So for us to complete the square, remember, the value that's going to go here, in both cases, is going to be b over 2a squared. So we'll just start here. So our b value is 6. Our a value is 1. So we have 6 over 2, or just 3. And 3 squared is going to be 9. So we want to add 9 here. If we add 9 to the left side, let's add 9 to the right side. Okay, so we would get x plus 3 squared. Over here, there is something, one more thing I want to do here. I want to factor out a 4. So the reason I want to factor out a 4 is because I know that when we're writing in our standard form, we can't have like 4y there. It's got to be just y. So now let's figure out what b over 2a is for our y's. So in this case, our b value is negative 2, our y value is 1. So b over 2a would be negative 1, and negative 1 squared would just be 1. So what I'm going to do is I'm going to add 1 in parentheses here. If I'm adding 1 to the left, I have to add something to the right. But notice here, I'm not technically adding 1. I'm adding 1 times 4, so I need to add 4 to the right side. Okay, so we are at then x plus 3 squared plus 4 times y minus 1 squared plus 9 equals 13. So let's subtract 9 from both sides, so we get 4 there. Divide both sides by 4, divide everything by 4 rather, so that we have 1 by itself on the right. And I'm running out of space, so I'm going to write my final equation down here. So on the right side, we get 4 over 4 is 1. Here we have x plus 3 squared over 4, and here we have y minus 1 squared. Those 4's cancel, so we're just over 1. And there we have it. There's our general form. So we can find our center by looking at x and y. So our center would be at negative 3, 1. Our vertices, so I'm noticing our value under x is larger than y, so it's going to be a horizontal ellipse. So a squared is 4 here, so that means a is 2. So our vertices will be 2 to the left and 2 to the right of our center. So at negative 5, 1, and at negative 1, 1. Our b squared is 1, which means b is also 1, so our co-vertices will be 1 above and 1 below. Next, we just need to find the foci. So a squared minus b squared equals c squared. Well, a squared is 4, b squared is 1, so c squared would be 3, or c would be root 3, which is 1.74, roughly. So 1.74 to the right, 1.74 to the left. So from the center, our foci would be negative 3 minus root 3, 1, and negative 3 plus root 3, 1. Okay. Kind of sloppy here. I know there was a lot of work there with completing the square. Completing the square is something we're going to continue to practice. You're going to continue to see, so just do your best with it as you're going through some of these problems.